Hey guys, this is Mr. Piercy, and what this video is going to be used for is to demonstrate the founding concepts of what we consider Euclidean geometry, which is typically studied in a high school curriculum. We're going to be looking at what are undefined terms, how undefined terms create things that can be used to create defined terms, and from there, how we identify them symbolically and how they interact with each other. Now, I have a little bit of a bone to pick with the definition that we're being provided here for what an undefined term is. The textbook says it's a word without a formal definition. Now, these three things here that we see underneath it, point, line, and plane, these are the undefined terms of Euclidean geometry. Generally, what we think of as an undefined term in Euclidean geometry is these are the things that create everything else that we will study in a high school geometry course. So point, line, and plane are the only three undefined terms that we have in geometry, and we can actually prescribe a definition to them. So I'm not a firm believer in the textbook definition of a word without a formal definition. Some of this stuff is going to be things that are pretty self-explanatory. By the time you get into high school, you've seen some of these things already. Go ahead and pause the video as you need to add any extra information to your notes and to get the terms copied down. But a point is simply a location in space that shows where something is. We might have it where two lines intersect. Maybe it's simply two lines intersecting. Maybe it's where they form a corner of a polygon or something. A line has no dimensions. It extends indefinitely in opposite directions. A plane is two dimensions. It's representing a flat surface, and it's formed by any three non-collinear points, meaning points that aren't on the same line. So typically a line can be like a flagpole that's sticking up out of the ground, or the lines that you see on the highway. A plane would be like a desk or a wall or a floor, something like that, as a representation in the real world. And again, go ahead and pause the video as you need to copy down any extra information. But some of this is duplication. I just like to have it as we go through it. Collinear points are points that are going to be on the same line. So coplanar points are points that are on the same plane. Lines can also be coplanar to each other. They can have lines that are on the same plane. Now here we get to the definition, what the defined term is. Generally what we think of as a defined term in geometry, aside from points, lines, and planes, those are the only undefined terms that we have. A defined term is going to be kind of a general characterization along with a set of defined or critical attributes that we assign to it. So I can say, if I wanted to give a definition of a term, like say the word space, it's the set of all points. That's general, the set of all points. That's boundless in three dimension. So that would be a critical attribute. So typically that's what we think of when we look at a defined term, is that it's going to be, it'll give a broad classification, but then it'll give a specific set of attributes that are assigned to it. That's how we define things, typically with vocabulary terms in geometry, although that's not the only thing that we use. A line segment is a piece of a line, and it has represented with a single bar on top of it. That's the symbol that we use. It's contained between two endpoints. And again, pause the video and copy down the extra information as you see fit. A ray is a part of a line that starts at an endpoint. Kind of sounds odd that you start at an endpoint, but that's what you do. And then you go in one direction. So here on the left-hand side of the screen, you see a ray called ST. It starts at S and it goes to point T, or it goes through point T. Now the symbol that we use to represent a ray is like this right here. It's an arrow. Now that arrow does not indicate a direction, and that is a common misconception by high school geometry students. They think that everything has to go to the right, and that's just a symbol for a ray. That's all it is. Opposite rays, or two rays that form a line, have the common endpoint and they go in different directions. So the examples of opposite rays are right here. And an intersection is simply where things intersect. Now, here, this is where two lines intersect, where two planes intersect to form a line. Imagine if you fold a piece of paper in half, the crease would represent a line where two planes intersect, and a plane and a line intersect at a point that you see there. Imagine if you just took your pencil and you put it on top of your paper to put a period or something. That would be where a line and a plane intersect. So the only three undefined terms, as I've explained already in geometry, are a point, a line, and a plane. A point has no dimension. It's represented by a single dot. Lines are boundless and they're one-dimensional, but they go in opposite directions forever. And you can see here how we're kind of showing how we name them. Lines have, it's maybe a little hard to see, a line that we would represent has arrows on either end of it, indicating that it is continuous. Plane doesn't really have a symbol. We just say it's plane such and such. But generally we would say it has to be, and I highlighted this part here because it's really important. A plane is formed anytime we have three points that are not on the same line. So that's really important. So here I can say plane A, B, C, or some variation of those. And, they have it here. I can call it plane BAC, as long as those are 3 points that are not on the same line. And typically they'll give us a capital letter that we can use to also refer to when we're talking about planes. So now we're going to take a look at some examples of how we're going to be using these terms, how they interact with each other, and how we can identify them. So in this example, we're asked to do two things. In part A, give two other names for line LN. So two other names that we can use for line LN would be LM would be a good choice. So I can simply turn the letters around. I could have called it line NL and be referring to the same thing. The lowercase letter b can also be used to represent the line, so I can call it line B. Give another name for plane Z. Well, any 3 points that are not on the same line can name it. So here are an example of how we can name them, LMP and plane NPL. Part B says name 3 points that are collinear. Collinear has to be on the same line. So here L, M, and N are on the same line. And name 4 points that are on the same plane that are coplanar. So L, M, P, and N are on the same plane. So those are coplanar. Now at any time, as we're going through the notes here, if you have questions about anything, of course, write them down and either email them to me or come see me in class, whatever you need to do to get in touch with me to let me know what your questions are. At this point, I need you to go ahead and pause the video and answer this question, and when you're done, hit play and check your answer and see how it looks compared to mine. All right, so hopefully you've paused the video and answered the question. Let's go ahead and see. Now, checkpoint 1, this question is referring back to the example one that we just saw the diagram there. It says, give 2 other names for line MQ. Well, MQ, I could simply turn the points around, call it QM. And of course, I use the symbol with the arrows on either end, indicating that I'm talking about a line. Or I can say line A. And the second part of the question, name a point that is not coplanar, so something that's not on the same plane. So point Q is not coplanar with points L, N, and P. Now moving on here, these are where we're getting into those critical attributes that I was talking about earlier with our defined terms. We're looking at segments and rays here. So line AB is written as symbolically, line AB, like you see typed here with the arrow indicating that the arrows on either end, showing that it's continuous. A segment is going to be with just a single bar without the arrows indicating that it's just a part of a line. Now, keeping in mind, when I'm talking about a line or if I'm talking about a segment, the order in which we name the letters doesn't make any difference. As you see down here, I can say segment AB, or I can say segment BA. I'm still referring to the exact same thing. With a ray, however, the first point that we use must always be the end point, or where the ray starts. So if I say ray AB, I have to start at ray point A and then go through point B. Whereas if I say ray BA, I have to start at B and then I go through A. Now note that those two rays are different rays, even though they use the same points. Because one part starts at A and then goes through B, and one starts at B and then goes through A, they're going in different directions. And in this case, they would not be considered opposite rays because opposite rays have to use the same endpoint. So ray AB and ray BA would not be considered opposite rays. So now taking a look at this example, we're looking at the diagram with the two lines intersecting. Give another name for segment VX. Well, I could call segment VX a segment XV. And keep in mind here on the left that when we're talking about the rays WY and WX, they have a common endpoint but are not collinear, so they're not opposite rays. And what we're looking at here, WX and, oops, I don't know why I picked that. Oops, there we go. Here's a ray, here's a ray. They have a common endpoint, but because they don't form a line, they're not going out in opposite directions, they're not opposite rays. So part B, name all the rays with endpoint W. Well, there's 4 rays that have endpoint W, WV, WY, WX, and WZ. Opposite rays with endpoint W would be WV and WX are opposite rays. WY and WZ are opposite rays. Now, at this point again, this is where you guys are going to check to see, are you understanding what we're doing? I'm going to go ahead and pause. At this point, go ahead and pause the video and answer these 2 questions. And when you're done, hit play and check your answers compared to mine. All right. So ideally, you have given yourself some answers here that you can compare and see what we have with mine. And then ideally, you're understanding everything that we're talking about and you have correct answers. So we're referring back to the segments that were, or the lines that were intersecting back in example 2. Give another name for segment WY. Well, that would just be, I'm sorry, YW. That would just be WY for the answer. And are rays VX and XV the same ray? So what do we have to say there? So in this case, no, VX and XV are not the same ray since they don't have the same endpoint and they go in different directions. So the second part of the question here says VW and VX, are they the same ray? Explain. Now that's why I'm trying to give complete sentences here. Anytime when it says explain something, try to use specific, be specific, refer to what you're talking about. So in this case, yes, VW and VX are the same ray. So I'm being specific. I'm referring to the rays that we're talking about in the question. And I use a complete sentence with appropriate math vocabulary. That's how we should answer things whenever we're asked to explain things in geometry. So here they are the same ray since they have a common endpoint, and point X and W are on the same side as point V. So they're both naming the same ray. Okay. Now here, this is where some students are going to excel and some students like me are going to struggle, where we have to draw some sketches of how these things are intersecting. Here in part A, in the example that we're asked to do, it says sketch a plane and a line that intersects the plane at more than one point. So that would be an example of something like this, where maybe the line is simply on the plane. Sketch a plane and a line that intersects the plane at more than one point. What the line is on the plane, it's intersecting it everywhere. So that's an example of that. Sketch a plane and a line that is on the plane, and sketch a line that intersects the line and plane at a point. It's not the easiest thing to read, so you might not understand exactly what they're asking you to do, but basically we have a plane point, where I'm calling it plane N, and we have basically what we had in example A, where we have a line that's on there. It's intersecting that plane everywhere. But then we have another line that's intersecting the given line at a single point. And that's kind of what point Q is doing to point, or line Q is doing to line P. So that's kind of what that one is supposed to look like. It doesn't have to be in that orientation, just with that basic information. So here, draw here we're trying to draw two planes intersecting. Now, again, two planes should intersect at a line. Imagine if you take a piece of paper and you fold it in half and crease it. Well, that crease is where, representing the line where the two planes would intersect each other. And this one's not the easiest thing in the world to do. Step one, it says draw a plane as if you were facing it. Okay, so what I'm going to do is, I didn't want to try and put this one on here just in general because I couldn't really make it nicely. So here I'm going to give myself kind of a plane, and I'm going to, uh-oh, Adobe Acrobat Reader died. Sorry, I don't know why. Anyway, moving on. I'm going to just fill in that plane just so I can have something to work with. And what it's telling you to do, it says draw one plane as if you were facing it. So that's what this is, this salmon colored thing here is. Then it says draw a second plane that is, in this case, going to be horizontal to the other one. And it's not really horizontal because if you're looking at it and it's horizontal, you're really not going to see it. So it's kind of like you're above it or below it. And so the way that I'm going to do this is I'm going to kind of, draw a line like that and draw a line like that, and then we're going to kind of come this way behind it, and then like that. And here it intersects, the two planes intersect at that line right there. So that's what we're looking at here. It says draw the line of intersection. So the first thing that we do is draw that kind of pinkish plane like that, and then we draw the plane that's intersecting it and identify the line that's going through it. And I stole a picture from online, kind of looking like that. It's not the easiest thing in the world to draw. I'm hardly an artist, but that's a decent representation. There's more than one way that you could do it, and some students are going to have different levels of artistic ability to be able to do that. So these are our final checkpoint questions. Go ahead and pause the video and answer these four. Draw the sketch in problem 4 and name the intersections in 5 and 6. So go ahead and pause the video and answer these questions. When you're done, hit play and check my answers compared to yours. All right, guys, so problem number 4, sketch two different lines that intersect the plane at different points. So essentially we just need a plane and two lines that are intersecting it at different points. So I have a point that's right there and a point that's right there. Something pretty basic, it doesn't have to be complicated. Where does line MX and line A intersect? That would be at point M. And name the intersection of plane C and plane D. Planes always intersect at a line, and in this case, those planes intersect at line A. So those are the foundational concepts of things that we talk about in high school, or otherwise known as Euclidean geometry. The undefined terms that we have are points, lines, and planes, because those make up everything else that we study. Defined terms are going to be things that have kind of a general set of things along with some specific critical attributes that separates them from, what's a ray compared to a line segment, that kind of thing. And how do these things interact? Lines intersect at a point, planes intersect at a line, plane and a line intersect at a point. So just a quick recap of what we talked about. But if you have any questions about anything that you've seen in this video, by all means, let me know. Get in touch with me. I'll be happy to answer your questions. But until next time, ladies and gentlemen, thanks for watching, and take care and be nice to each other, okay? Can't stress that enough. Just be good people. Anyway, talk to you later.